Okay, good afternoon, everyone, and welcome to the Sharjah Academy for Astronomy, Space Science and Technology. We have another lecture on the program as related to the celebration, to the 1 month celebration of women and girls in astronomy that has been set by the International Astronomical Union. We are very privileged today to have Miss Maryam Sharif. She is a research assistant from the Meteorite Center, and she'll be talking about a very exceptional lady, Henrietta Leavitt. She is, as we say, usually we say the mother of what you call doing research into stellar brightness or stellar spectroscopy. She was the one that was able to find this very famous relation between what you call the period and luminosity of stars, and this is very important in terms of finding distances and so on. So Leavitt has done a lot in this context, and she is credited with the with this what you call this PL relation that is so important in stellar astronomy. So I invite Maryam to talk about her, and hopefully every one of us will benefit from this lecture. So please, Maryam, go ahead.
Thank you very much, Professor Elias, for this great introduction, and welcome everyone. Actually, I'm delighted to be part of this Women and Girls in Astronomy celebration, and I wanted to highlight and talk about an exceptional woman whose discovery greatly impacted astronomy. This lady names as Henrietta Swan Leavitt. Okay, so for today's talk, we'll talk about her, and we'll talk more about how her discovery impacted our astronomy and our study in astronomy and measuring the universe. So we'll start off with a question that you might ask. I know the slide is not moving. Sorry for that. I'll just stop sharing for a moment and I'll try again. Can you see the screen now?
Yes, we can see the screen. Thank you very much.
I'm not sure why the slide's not moving. Sorry for this.
Maryam,
can you see the slides now?
Not yet.
That's
you can ask Aisha to help you if she is nearby.
I believe now you can see.
Yeah, we see the slide, yes.
Okay, great, now it's moving. Okay, so to continue on our today's talk, so as I've said, that there is a question that you might ask, that how can astronomers possibly know how far away stars and galaxies are? So by that, the first method that astronomers ever used to measure the distance to stars was something called parallax. Now, to get a better understanding and to demonstrate this, the parallax effect, so I want you to do this little exercise. So I want you to hold your thumb up and extend your arm all the way out. Now look at your thumb. I want you to blink one eye and then try the other eye. So you would notice that your thumb seems to shift just a little back and forth, that with respect to the objects in the distance background. Well, this is easily explained as you are looking at your thumb from a slightly different angle with each of your eyes. Okay, so now I want you to hold your thumb even closer to your nose. Repeat the same exercise. Close one eye, look at your thumb, and then close the other eye. Now this time, you will have noticed that your thumb had much larger shift with respect to the background objects. You can see this image have a good representation. What you see, like what you can see from the left eyes, and what you can see from your right eyes. Now you can actually calculate the distance nearby star by measuring how much they shift relative to more distant background stars, as what we have done in this exercise. So here I will play a video that will have a better explanation. I'm not sure if you will hear the sound, but I will try to explain if not. So let me know if you hear anything or not. You hear anything?
No, there's nothing, but that's fine.
Okay, so I will explain it instead. So it says that, like, however, if you have traveled in a car, then you see like the objects in the background distance, that you have noticed that the closer objects moving faster than the further objects in the background. What this actually explains the stellar parallax and measuring distances. So as you can see that you are the observer as the car, then you can see the nearby objects and even further the background objects. So you can see that the shift for closer objects is greatly than the objects in the background. So that is the same thing happens in our stellar measurements. So if we are in the Earth and we see the star here, as you can see, this is the Earth and the Sun, nearby star, and that the distant fixed stars. So when the Earth, from this point, visualize the star, for example, in December, we are here, and then we measure again, take the measurement in different, for example, in August. So what happened here is that this measurement that we take in December, and then we take like over 6 months to in June, and we have measured, take the measurements, we have this, the parallax shift, and then we get the parallax angle. By knowing the distance that we have, like from the sun to the Earth, that's one astronomical unit, we can get out the distance using that trigonometry calculation. Okay, so maybe that was that. So here is a better maybe explanation that we can calculate the distance to nearby stars by measuring how much they shift relative to more distant background stars, as we can see here. This image actually was taken from that video to have a better illustration. So when we take a measurement from Earth by this period of the year from December, and then take the other measurement of that same nearby star that we want to measure the distance from, we get this, the parallax angle, and we do the calculation to measure the distance based on the fixed stars in the background. So that was the same as the exercise that we have done. So it's like our eyes were the left and the right eyes. Okay, so we're having this called the baseline that we helps tremendously in calculating that nearby object. So we have here the parallax formula states that the distance to the star is equal to 1 divided by the parallax angle. So by that we can get the distance to the nearby star. But there are some limitations with this method, that this method can only measure nearby star, as the stars parallax only measure the nearby stars, like we can say approximately within 100 light year. So what is a light year? A light year is the distance that light travels in 1 Earth year. So the 1 light year is about 9 trillion kilometers, if you can estimate. Okay, so what about measuring further distance star? So this method will not help us in measuring further distance star, as the amount of shift would be very minimum that we cannot even notice. So here comes the role of Henrietta Swan Leavitt. So Henrietta Swan Leavitt, she's a daughter of a constitutional minister. She was born in 1886 in Cambridge. She attended Oberlin College and graduates from the Society of Collegiate Instructions for Women in Wycliffe College in 1892. So during her senior year at Radcliffe College, she took a course in astronomy. And from that moment, she felt really interested in the field of astronomy and wanted to learn more and more about it. So after her graduation, she became seriously ill and was left for dead for her life. So however, in 1894, she was eager to find work in the field of astronomy. Well, but that time, women were not really encouraged to work by her time. So, but she was seeking for a career to lead her to get into the astronomy in the field of astronomy. However, at Harvard College Observatory, the director, Edward Charles Pickering, who's an astronomer, had a problem actually at his observatory. That it seems that the observatory was collecting far more data than his astronomers could handle. And he would have to hire a staff to do a lot of computational work. Well, if he hired men, he would be obliged to pay them a decent salary, and his budget was very limited. However, women were considered as a cheap labor. His budget would be just like to cover a staff of a female, as computers, as they were known by that time. So Harvard computers are the name that women who examine tiny dots in time-exposed photographs of night sky that measure and calculate recorded their observations in later book. So here is a picture where they call it the Pickeringham group of women, as they worked as computer at the Harvard College Observatory in 1889. We can see here Henrietta Leavitt in this image, as she joined this group of women as part of her astronomical research. But at the beginning, she worked as a volunteer. She was not getting any salary for her work by that time. But after that, the Pickering awarded Henrietta a salary of like 30 cents an hour, and placed her in charge of poring over a glass photographic images. The glass photographic plates to look for. As you can see here, we have the glass photographic plates on the right. Okay, so her work was to look for variable stars. As you can see here, demonstration of a variable star. So what is a variable star? Well, it's a star whose brightness changes over time. Well, some variable stars, like they can change over a time with a constant variation, while other were not. But Henrietta's focuses was on a specific type of variable stars called the Cepheid variable stars. So it was called Cepheid variable stars due to the prototype star Delta Cepheid in constellation Cepheid. As you can see here in the image on the right, you can see the constellation, and the Delta Cepheid was the prototype star that we started to work on. So we can see here in this image the Magellanic Clouds, the small and the large Magellanic Clouds, where the work of Henrietta was on. So we can see here two irregular dwarf galaxies, but they are visible only in the southern celestial hemisphere. So these Magellanic Clouds have played a significant role in our understanding of the distant universe. But by Henrietta's time, they didn't notice that these are galaxies, but they thought that they are just like constellations of dense stars at that time. So Henrietta discovered the period luminosity relation of Cepheids while studying variable stars in the small Magellanic Clouds. So this became one of the most important relations determining distance to objects in the universe, and forms the first rung of extragalactic distance ladder that we'll talk more about in the coming slides. So Cepheids variable stars. So what did Henrietta's noticed, or greatest noticed, that she found the relationship between Cepheids brightness and their length of time, that it took a complete one cycle, as we can see here. That here we have the time and the x-axis and the brightness, and we can see that as if it repeats itself over a time. So Cepheid variable stars expands and contrasts in a predictable rhythm, so causing measurable periodic variation in its luminosity. And the period of their fluctuation happens to be proportional to the luminosity of the star. So Cepheids variable stars that are emitting more power fluctuate more slowly to have longer time periods. So if we have two Cepheids that share the exact same period of variation, then the one that appears brighter to our eyes from Earth must be closer of the two. So what did Henrietta discover? She discovered a direct correlation between the period and luminosity fix for Cepheid variables to go from bright to dim and back, brightness of the stars. We can see in this graph over the time and the apparent magnitude of that star. So the longer the period fluctuates, I'm sorry, in this graph, we can see that the period with the maximum brightness, so the longer the period it takes, it means that it is much brighter, but the shorter period it takes, then it's dimmer. That means that even though that we have a star seems dim, if it had a longer period, then it must be large. So to calculate how bright the star appears from Earth, she calculated how bright the star appears from Earth and compared it to intersect brightness. That could estimate how much the star brightness had faded away while reaching Earth and the distance of the star. So this is her greatest discoveries between the period and luminosity, as we can see here in this graph, that helped tremendously in determining the distance to stars by following like this equation, as we know the luminosity and the apparent brightness of the star, then you can easily determine the distance to the star. So this is Henrietta Swan comment on her discovery, that she says that a straight line can readily be drawn among each of two series of points corresponding to maximum and minimum. That's showing that there is a simple relation between the brightness of variable and their periods. So she published a paper in 1908, and the paper titled 1777 Variable in a Small Magellanic Cloud, as you can see here. Now, this paper is one of the most important papers in all of astronomy. Well, Henrietta passed away at the age of 53 after a long battle with a stomach cancer. But by that time, she didn't notice that her discovery and the effect of it in our modern astronomy. So the effect of her work, he's a Danish astronomer and chemist. He used her discoveries to plot the distance of stars. Also, Harlow, he's an American astronomer who used her discovery to measure the size of the Milky Way. And Edwin Hubble, he's an American astronomer who created what we know now, the Hubble telescope, used her discovery to discover the edge of the universe. So all of that work happened after her great work accomplished in discovering the relation between period and luminosity. So what she has accomplished, she was an American astronomer of the first finding the magnitude. Her research resulted in advance within the field of astronomy that we use her discovery today in measuring the distance to faraway stars. And she discovered how to rank stars' magnitude using photographic plates. And also she discovered a way to accurately measure extragalactic distance by using the period luminosity relation. And she discovered more variable stars than any other astronomer in her time. She's also a member of Pi Beta Kappa, the American Association of University Women, the American Astronomical and Astrophysical Society, the American Association of the Advancement of Science, and an honorary member of the American Association of Variable Star Observers. So here we can see an interesting image that shows Henrietta's lifetime with what happened during that time. So we can see by 1869, Mendeleev makes the periodic table that by the time she was born, and as we can see that she attended the Oberlin College, attended then the Radcliffe College, and she volunteered to work at Harvard College Observatory. That was like as volunteering, but then she got paid to work at the observatory. And then by that time, she discovered the Cepheid variable stars and developed the period luminosity theory that we use it now, and published her theory by 1908. And then, by that time, at 1921, she died because of stomach cancer. Before that time, that as you can see in the top, that the World War I was began, and also women were given right to vote in the US. So this is interesting to show her lifetime with what was happening by that time. Now, regarding awards and honors, well, the asteroid 5383 Leavitt and the crater Leavitt on the moon are named after her to honor the women and men and women who worked as astronomers. And unaware of her death 4 years prior, the Swedish mathematician Costa considered nominating her for the 1926 Nobel Prize in Physics and wrote Shapley requesting more information on her own work of Cepheid's variable. But Shapley replied to that Miss Leavitt were dead by that time, and suggested that true credit belongs to his Shapley's interruption of her findings. So Henrietta's Cepheid variables are known in astronomy as standard candle. Now these standard candles are very useful in today's, like in measuring the distance in the universe, as we can see in the image on the right. So for the first 100 light year, we used it like the parallax, and then for the more further stars, we use the Cepheid variables, and even for the more and more further stars, we use different methods, but this is not the scope of this lecture today, so not go to talk about now. So now these standard candles are I mean, if we collect different standard candles, we have a collective standard candles, and by that we have something known as the cosmic distance ladder. So this is, as you can see on the right, the cosmic distance ladder. So we can see that for the solar system, we are using the radar ranging, and then we have the parallax for the nearby stars. But for the Milky Way, there is another method that is used. For the nearby galaxies, we use the Cepheid's variable stars and the work of Henrietta was basically here in discovering the relation between period and luminosity, and other works were built after that in measuring even, and knowing that by that time that our galaxy is not, is not the only galaxy in the universe. However, we have other galaxies, and the universe is expanding as that. So now these cosmic distance ladder and the standard candles allow us to measure distance of billions of light years. Now it was Henrietta Swan's work who handled us a ruler to measure the nearby universe. So we wouldn't go further if we're not of Henrietta's great work. So by that, I reach to the end of today's lecture. And I would like to thank you for listening, and I would be happy to answer your questions.
Thank you very much, Miriam, for this nice presentation that you gave us about a very famous female astronomer, Henrietta Leavitt, and her work in terms of finding distances to stars and also to galaxies. So I open the floor for anyone who has a question. So you may check your chat if there are any questions, Miriam. Again, so any questions, please? There is a question. There are two questions here for you. You can read them. What is the thing you liked the most about Henrietta, and what can girls in this field learn from Henrietta? So can you answer this?
Yeah, well, the most thing that I liked about her, that even that she were facing a lot of like illness problems, but her love and passion toward astronomy never stopped. And even that by the beginning of her work, she was only working as a volunteer, and she was not getting any wage of that work, but she kept working because that she really loves that field. And about the second question, what can girls in this field science learn from Henrietta? Well, maybe that to keep to keep doing what you love to do, that would really help. You never know who would benefit from your work, of that, the passion that you have, and maybe to focus on tiniest detail as what Henrietta's done. That even that there's a tremendous huge amount of photographic plates, but she kept working and figuring out that great relation of that the period and the luminosity of the Cepheids variable stars, and she figured out the duration that it takes, and so even looking at the finest details, it could help, like no matter how small you are or how but you never know what's like a great work that you can accomplish with. So never underestimate yourself, and of course you would be a great contributor to the future generations. So
yes, her perseverance in doing something that very few can do, especially as men, because she had, as we said, she had to look for hundreds and hundreds of photography plates, and her first paper, 1,777 variable stars, it was a great contribution to what we know today about how to figure out how far away are stars and so on. Any other question, please? Okay, so everyone kept silent. Okay, thank you again, Miriam, for this very nice presentation. So again, we are celebrating since a month the IU celebration of women and girls in astronomy. And up to now, I believe the Sharjah Academy for Astronomy, Space and Technology has given more than about I believe 15 lectures, and we still have one tomorrow. Tomorrow, March 8th, is a very special day for women. It is, as we usually say, Women Day. So when we celebrate women, that woman can be my wife, can be my daughter, can be my sister, can be my colleague, research assistant. So it can be anyone. So tomorrow there will be also another presentation by Miss Selma Subhi. She will talk about meteorites. So we'll have a rendezvous tomorrow, inshallah, a little bit earlier than today. So the lecture tomorrow will start at 12 o'clock. And there will be an announcement about it at the university website. Again, thank you very much, Mariam, and thank you for all those who attended with us, student, faculty member, research assistant, and hopefully you have benefited a lot. So thank you again. Wassalamu alaikum.